So let's continue now with positional axis, which is the cousin of loc, but which, as we described earlier, ignores the label values and simply thinks of these data frames as m by n tables that are numbered from 0 to m minus 1 and from 0 to n minus 1. And because it's strictly numerical, very NumPy Python list-like, then slicing is purely exclusive. So for example, if we look again at the structure of our elections table, if we ask for, let me change this so that there's a slight difference between the two. If we look at these, if we ask for a slice that goes from 0 to 3, this is going to be 0, 1, and 2 in the row dimension, and 0 to 4 is going to be 0, 1, 2, and 3. These are going to have 3 elements and 4 elements. Remember that in NumPy, by the way, you can omit the start when 0 is the start. So you can say from the beginning until 3, and I often find it a little bit clearer to write code like this, actually, because it reminds me explicitly that I'm saying from the start until 3, and you could say 2 till the end, for example. And so in this case, this was the whole data set. And so from the beginning until 3, it's going to be these first 3. And then from 2 to the end is 0, 1, 2. It's going to be this until the end. So this is, we're basically cutting this part of the data frame. And that's exactly what we see right here. Whoops. Sorry about that. This was a little leftover from from a previous run. And so we will be using both loc and iloc in the course, and there are situations where when you're doing purely numerical operations where iloc is useful, but by and large I strongly recommend that you use either square brackets or, for the most part, loc, because as I said before, you're referring explicitly to the structure of your data, to the labels that you've provided. This is what has meaning. So if at some point you change the way you organize your data and you move a column around, or you move or you add new rows, then the fact that column 3 became column 4, column 5 isn't going to break all your code. Whereas it's extremely easy with iloc to do things that will break inadvertently, and they may not break in ways that are obvious to you. So if your code stops working, you're fine. You'll have to debug it, but at least you know it stopped working. The much more dangerous problem is that your code now gives answers that are incorrect, but they look vaguely like they might be right, perhaps. They're kind of reasonable in a broad sense, but they happen to be wrong. And those kinds of errors are very difficult to detect. So in order to test a little bit of your understanding, we're going to have a bit of a challenge. So as I've said before, we're focusing on the slides, on the notebook. I'm sorry, I'm trying to use the notebook interactively so that we can actually see what happens. But all of this is stored for reference in the slides, and we have links in the slides to all of the documentation. And this is a topic where you really want to read up a little bit on these. And so everything we've done so far is available to you here. So now let's end this section. Well, actually, before we move into sampling, which is the last thing we're going to do in this section, let's actually try to think for a second about which of these expressions is going to return the data frame of the first 3 candidate and party names for candidates that won more than 50% of the vote. Okay, so let's take a look here, and you should think for a moment about what's happening before you actually run it. So now we are going to take a little challenging question to try to make sure that we understand these accessors correctly. And in particular, I want to make sure that you take a moment to think through these before you run them. Don't just hit Shift-Enter blindly. Take a moment to stop and think. So the question is, which of the following expressions are going to give us data frames for the first 3 candidates and the year, so the candidate name and the year, for candidates that won more than 50% of the vote. So let's take a quick look at the data. When did that happen? So that happened first in here. So Reagan in 1980 was the first candidate for whom the vote was more than 50%. Then after that, this one, Reagan again in 1984. and then it happened again for Bush in 1988. So we want Reagan in 1980, Reagan in 84, and Bush in 88. These are rows 0, 3, and 5, and columns, what we're looking for is the candidate in the year. So this is the candidate column and the year column. Candidate column is column 0, 1, 2, and 3. So this expression is actually going to give me exactly that. It's going to give me, I'm selecting rows 0, 3, and 5, and columns 0 and 3, and we get exactly what we wanted. Now, obviously, it's kind of cheating because we looked at the data, and then we counted, and we picked that out. So this is a slightly different solution that gives us almost the right answer in the sense that we do get the right information, but if our condition was candidate and year, then this actually gives us a little bit more than that. It doesn't give us, because we're using a slice, then we get from candidate to year, so we get extraneous information in the middle. We get two columns that we didn't ask for. Now this is a different solution that provides us with now something that it's a little bit less cheating, right? Because what we're saying is now the same information, but we're saying give me when the election percentage was more than 50%, give me the candidate in the year. And so this is probably the kind of code that you should be writing when you're actually asking something from data. And what about this last one? Well, almost, but not quite. We then accessed with iloc at the end, and the problem is that this slice, remember, iloc uses integer, traditional integer slice semantics in Python. So this doesn't give us positions 0, 1, and 2. It's 0 through 2 open-ended, so it's only 0 and 1. If I had done this, it would give me the right answer, but in this form, it is not quite what we're looking for. Okay. And so finally in this section, we're going to talk very briefly about sampling. So pandas make it really easy to basically, since we think of them as a sample of some population, you can subsample within a sample, and they have a method called sample. So if you call it multiple times, you keep getting different answers, as you should, right? Each sample is a new sample drawn at random from your data frame, by default without replacement. Though, whoops, let me not change that. By default, sampling is done without replacement, but you can say replace equal true if you want to do sampling with replacement. And so this makes it very easy to connect pandas to bootstrap type computations and to do those kinds of things on data frames, because anytime you can, for example, combine queries with the generation of samples for bootstrap with simple expressions such as this one. This should give you a bit of a flavor of the power of pandas. We're going to take a pause right now, and we will continue next with we're kind of done with accessing the data, and we're going to look at some higher level functions that are not accessors next.